Hello and welcome to Technically Speaking, where scientists and engineers come together to chat about a common interest, share knowledge and satisfy some curiosity. I'm Laura and I'm joined by Rwayda to talk about 3D printed materials that could be used in construction projects to make better buildings, but were originally developed for a very specific, different application. So I found this really cool piece of research about metamaterials. It's a mesh of tiny 3D printed gears where you can change the stiffness of the metamaterial by rotating the gears through a particular angle. So it was designed with robotics in mind. So the robot can be soft while it's moving around, but strong while it has to carry something heavy. And this is what got me thinking about other applications. So Rwayda, I thought you might be interested in this.
Yes, it's really interesting for civil engineers to know what's happening in the printing world because we need to build bridges and other form of construction. So such material could have a good application in the bridges in the future because if it changes stiffness, and if we think of London Bridge when it's open and closed, that could be really helpful to have such a material.
Yeah, and I remember in the episode we did about bridges, you mentioned dynamic load, where the bridge has to put up with a whole variety of different forces going through, like when it's really windy or when a lot of people are walking across it. It has to be able to withstand effectively different conditions, but using just one material. So I got the impression you're a bit limited by your material's properties. Does that sound right?
Yes, the material properties would be limited on where you put the bridge, really. So if you have strong wind, that would cause the bridge to shake on the other direction and would cause wave in the bridge. Also, as you mentioned, human walking on the bridge will cause like a dynamic load coming from the movement. And these load comes in cycles, so it's good to have a material that could adjust to different type of loading.
Yeah, so I'm imagining like when it's really windy, sometimes bridges get close to certain vehicles. Like you just make your bridge go really floppy so it can wave around in the wind all at once.
Well, as long as it's safe to keep the car on.
Yeah, you still might have to close it in that case, to be fair. I'll explain more about this metamaterial because it sounds like a bit of a weird niche term. So basically, the research paper that I was reading, the scientists had designed these 3D printed gears. They're made of plastic and they print them directly into a grid layout. So they're not assembling the grid layout after printing the gears. They're doing the whole thing sort of in position. And I said the gears are really tiny. They're like no more than 4 mil in diameter. And they've got tiny, tiny teeth. They're a few hundred microns wide. And the research paper gave loads of stats about the mechanical properties, about strain and stress and all that sort of thing. And I'm not too familiar with what that means necessarily to a civil engineer. So can you sort of help explain some of that to me?
Okay, so we can start with the tensile stress of the material. If you think of having a cable and you pull it to stretch it in both directions, the load you're applying is in Newton and it affects the cross-sectional area of that cable. So the tensile strength is load over area for this cable being pulled in both directions. And that would apply to the material that we're talking about. So it's basically how much load it would stand until it breaks, being pulled in two sides. In the paper, it seemed the strength depend on the gear's angle.
Yeah. So the idea was that if you rotate the gears, they all line up in one particular direction, then they'd have like a really high tensile stress or something like that. And then if you rotate them through another angle, so they're sort of rotated a different way, they'd have a very different tensile stress. They could be like really strong or not. I feel like I'm not getting that quite right. You're the expert here on materials properties.
It seems from them, they start with an angle of 12 degrees and they increase the angle to 78 degrees. And the strength was for the 12 is about 1 megapascal. And megapascal mean is Newton per millimeter square. So if you go back to what I was saying in my example of having the force, which is how much you pull, and the cross-sectional area of the section. How did they estimate their cross-sectional area? Because they could do net or gross. It's basically is it the area of each gear and each layout, or is it the gross area of the cube they used to find the tensile strength? They did not mention that in the paper.
I would assume it would be because they talk about the metamaterial, so the gear mesh as a whole, right? So I think it'll be the cubes that they measured rather than just the area of the gears.
Yeah, I think that would be the case, but they did not say anything, so I can't comment on that.
Fair enough.
And it's basically how much force they will require to break it. Taking that into consideration, how this material would change, because it's tiny at this point. So if we want to use it for bridges, we want to make it bigger. Is this number will increase in a linear way, or will they not be linear? And the other question is, how dependent is the properties on the mother input material? Because in this case, they have plastic or something in to print these gears.
Okay, so there's three different questions going on here. So I'm going to take it back to what you were saying at the beginning about the megapascals. So that's force per unit area, and you said that was up to 2.5 megapascals of tensile stress?
Yes, that's between 1 to 2.5. That's what they got.
Okay. So how does that compare to traditional construction materials like concrete and steel?
So concrete tensile strength measured to be 10% of its compressive strength. And the normal concrete grid is 30 megapascal, and 10% of that is 3 megapascal.
Okay, so compressive strength is if you're trying to squash it, it's how much load it can take before it shatters.
Yes.
And then the tensile strength is a fraction of that, and if you're trying to stretch it.
Yes.
Okay.
And it's difficult to measure it in concrete. That's why they have this estimate of it's being 10% of the compressive strength of concrete. So it seemed to be very comparable in terms of strength for concrete, but concrete is not really good in tension.
Mm-hmm.
So it seemed to be at this point as the lower end of the construction material. So the one that is the construction material, like it's really good in tension, is the steel. And the steel will have a much higher 100 something tensile strength that would carry that same load. And the whole idea of reinforced concrete came from merging. So concrete is really good in compression and it's cheap.
Mm-hmm.
Steel is good in tension, but it's expensive. So that's why they have the bars when the member is in tension. So this material seemed to be similar to concrete, but we don't know because it's still kind of tiny on that measure, if that makes sense.
Yeah, this is what you were saying about, does this graph of the properties that we were looking at, is it linear? Does it scale up? So if you made your metamaterial bigger, could you just multiply the tensile strength or the tensile stress by the size that you, so if you make it 10 times bigger, is the tensile stress like 10 times better or the same?
Yeah, it could be much better, and it could be behaving like reinforced concrete, which is a mixed concrete steel, but it could not be as long as we don't have a bigger scale test. And I'm really very curious on how dependent this material is on the properties of the mother material. I'm calling it the mother material. I'm not sure what the right terminology of the word is, because you would input some material in that already have some properties, right?
Yeah.
The shape is not the only kind of factor that determine the properties of the material, is the strength of the original material. So let's say we put the concrete casted into a mold somehow with 3D printing that look like these gears. So we know the original strength of concrete, so how much that would be impacted by making it to a gear.
But I don't think they're suggesting that you would use something like concrete to make these gears necessarily.
Yes.
I guess they were using the plastic in this case because that's what 3D printers tend to work with. I know you can also 3D print in metal.
Yes.
But that sounds like it would be much more expensive than the experiment they were doing, to be honest. But I really liked this idea that you've got this material that you can just change these gears somehow, and it completely changes what your material can do. And I can just imagine, because they were doing it for robots, right? I can just imagine this robot walking around like being really floppy to get through a gap, and then suddenly stiffening up when it has to like drag something out of its way. You can just imagine it like an animal crawling around, being able to adapt to its environment. It sounds like you wouldn't do the same for something like a bridge necessarily. You wouldn't have it crawling around for a start.
Well, maybe we'll have this like flying bridge. I need a bridge here, and it comes and fly and do itself to a bridge, like the robot, like a robot bridge.
Yeah, or some sort of a house that just like, I can't be bothered to go home. I'll get my house to come to me, and then it just lives there, and it's 3D printed out with these gears, and it's brilliant. It looks after you, it follows you around.
Yeah, like a shell.
Make my house like a snail. Yeah. You were saying that the tensile stress or the tensile strength of the 3D printed material is nowhere close to steel. So maybe we're not going to use it in civil engineering projects just yet.
Yeah, maybe with metals, because they printed them now is out of some plasticky looking material. Maybe when they printed the same gear they have in their metamaterial in a form of a metal, maybe the behavior will change. We don't know yet.
Yeah, I mean, this was the research paper that I saw. It was very much sort of lab based, like almost like a proof of concept. Like they printed their gears in different ways to improve the material properties even further as well. So there was a lot of mechanical engineering you could do with this material to give it particular tunable properties to make it like really stiff and really floppy in the same instance, which I thought was great. So I can definitely see there's like more work that could be done to improve this even further and turn it into a real world application.
Yeah, I totally agree on that.
Yeah. But I get the impression that there is something else going on in civil engineering that uses 3D printing in a slightly more practical way. Have you come across anything like this?
Yes, so now they're using 3D printing for new housing. They use the big printers to print the housing concrete and add some material to it. The houses look really cool. In Germany, one of the companies won the Innovation Award for the year in 2021 for building one of these 3D printed housing. And these houses are quite cool.
Okay. What specifically did it win that award for?
So there are lots of control that you would have on the final product when you build with this. So it's more consistent. It eliminates human error. It saves labor. And it's cost effective, is more sustainable because it's a quality assurance on the site because you have the machine doing your concrete casting. So it have lots of advantages that they seem to think it would be the new building in the future.
Oh, okay, so 3D printing is doing people out of jobs because you don't need people like laying bricks instead.
Pretty much that's one of the thing that does. And once you invest in the set, right, when you have the equipment, once you invest in that set first time, it's going to be much cheaper for you to build more and more houses. And because it's like you would input the map and the design into this machine, you can pretty much be flexible on what you want, like the layout of the house, I mean.
Yeah, and you've mentioned before that concrete's quite formable, so you can make some really interesting shapes with it.
Yes, so that's what they're doing. So you can see, like, if you Google these houses, they're very curvy and kind of like they look like future houses, like more. I don't want to say it's more modern. It's not about modern. They look like something that you've seen in a movie with all the curvature because they get to do it easily in these 3D printing kind of like big concrete thingies that they're using to build them.
Cool. I'm going to keep bringing robots into this now. I can imagine you've got these robots sort of crawling around, printing these walls for you, and the people just kind of sit there chilling out, letting it do its thing.
Yeah, and it seemed to be very cost effective because it seemed the labor cost is one of the huge costs that they're reducing in these projects. And since the quality assurance is quite high, so even they would be able to control more the environmental impact.
How would they do that? Because I know concrete isn't necessarily an environmentally friendly material because it's got quite high greenhouse gas emissions.
Well, there are a few things happening with the concrete now. So they're trying to reduce the cement content and add other additives to make it more kind of like environmental friendly. So there's a lot of way that trying to do that. But it's because the machinery and the traditional machinery and moving the materials to distances to come here to where you build having the 3D printer do that, because people need to commute to come, labor need to commute to come, and all of that is costed as an impact on the environment, right?
Yeah.
So by having machines and you move them on one go, they will have less of impact. And it seems the machine itself, the huge 3D printer that they use to build the houses, does not mean they have a big carbon footprint. So that's the other thing that they're saying. The quality of the building itself seem to be much better because it's higher quality assurance, will make it more sustainable in the future.
Yeah, so something that should last longer, be more affordable, and be built to a higher standard with fewer carbon emissions during the construction process. That's like the definition of sustainability, different sustainability pillars.
Yeah, that's why this house won this innovation award in Germany. And it seemed there's somewhere here in the UK, south of England, forgot the area location, have started investing on building the 3D houses in the UK.
Oh, okay, so it's spreading. Ah.
Yeah, but seem to be quite big in Germany at this point.
Cool. We were talking at the top about the mechanical properties of this 3D printed metamaterial that's made out of tiny gears. So I'm assuming concrete being a more traditional material, it's only got one set of mechanical properties. You mentioned concrete, it's great under compression.
And that's one of the reasons now most of these buildings, because they using most likely reinforced concrete, is focused on houses. Because like it's 2-story house, it does not have that high load in it. I still have a long way to do bridges, skyscrapers, and other forms of building that they still can't fully use 3D printing into them.
Oh, okay.
So that metamaterial could be something that do that in the future.
So is that because I think in the skyscrapers episode again you mentioned like the winds that are swirling around these really tall skyscrapers. Again, they create this dynamic load that you have to account for somehow.
Yes, you have the dynamic load because the like if you think of it as kind of shaking, but you want it to be flexible enough to shake, because if it's rigid, it will just snap. So you want it to have a bit of movement, but not too much movement. And such a material could be the way to do that.
A 3D printed concrete structure wouldn't have that flexibility to build something that high that would last. Is that...
Not yet.
I feel like I'm learning so much about how to build everything.
Yeah, because like these buildings usually are framed of steel, but maybe the metal 3D printing is better for the environment because the steel is quite harsh, because the steel is the way you produce the steel is quite intensive on carbon emission. It's not as high as concrete, but it's also like you need to melt it, use furnaces and all of that, then move it to the place. I'm not sure what metals this 3D printing can do, but I'm sure they will get a way to do some metal thing that would replace the steel frame.
Oh, that's interesting. So I know a very little amount about 3D printing using metals, and you start off with a powder and you melt it with a laser, so you can sort of move your laser through the powder, and where the laser's been, the powder melts into a solid object, so you can see that you could form all these different shapes out of this powder. But how you translate that into construction, I have no idea. That sounds like quite time intensive.
It could, like, it's time intensive now, right? If you think of the way that computer changed over the future, and even if you think of the smartphones, like in the early 2000s, they were kind of like something you would see in a science fiction movie. So you don't know how fast these technology develop, and now we have the AI working with us in so many ways. So maybe they will find a better way to utilize this if they found a really good application for it in civil engineering, which make it build more efficient, and they can save money on labor, and they can save money on the emissions, and it would be more sustainable. So maybe it's gonna be something that the future building would look like.
One thing you'd want to do is reduce how much steel or metal you use in your construction project, right? So you kind of 3D print all these sort of almost like lacy structures. So you've got like little holes in there, and it would be just as strong because your AI is kind of like figured out how to put these holes in certain places without affecting the material's properties. And you just have this really beautiful, printed, wild-looking structure that you could never really think of yourself.
Yeah, and also it could have like how light this structure will be, because it would kind of like would be able to remove redundant material here and there, and would save you cost on the overall project because it have less material on it.
Yeah, exactly. So you're saving emissions, you're saving time, you're saving materials. That is the future.
And one of the things that I forgot to mention before, and the advantages of 3D printing, is you save waste material, so it's not as wasteful as normal construction building, because it's utilized the whole mix and everything, because it's kind of like, well, I don't want to say perfect, but they're aiming for perfection because it's a machine, right? And it just use every little bit of the material it have in it. So they would eliminate waste as well.
Yeah, so rather than sort of making a block that you then sort of shape down, so you're sort of reducing stuff from the surface of it, you're just putting in place exactly what you need.
Yes.
Yeah. Cool. See, this is the future. We need some engineers and scientists to get together and collaborate on putting this idea into action, I think. I feel like I'm coming at this from a really weird way because I'm a scientist, right, who's just interested in like really fundamental stuff. And then you sort of pass that fundamental understanding on to the engineers to find applications. That's what we're doing, right?
Exactly. That's why like we're kind of like using this initial material that they have to see what potential it could do for the future, because like it can do so many things, but we don't know yet. It's like we have a limited sciencey research to give us enough background to kind of like have a more firm conclusions.
Yes, there's more research to do to figure out what 3D printing can do for us. It sounds like there's a role for slightly crazy ideas like some of mine to do something that no one's thought of doing yet.
It's really good when you talk to someone from outside of the field, because they would look at things differently. So some of these wild ideas could be very applicable.
I love it. Thank you. Because I feel like I'm just spouting utter random things, and loads of people be listening to this going, that woman's crazy.
I don't think any scientist will be crazy, but we would all have some kind of like other layer that we have this wild ideas, and it could work and could not work. But that's how science works, right? Like that's how science move. Because again, like if you look at the science fiction movies from the 70s, like Star Wars and things, everything there seems like that can't happen. And now we have space travel.
It's a slightly different thing, yeah, and I'm sure people have looked at those films and said, oh, well, that can't happen because this fundamental law of physics. I see your point, and it allows people to dream, right, and think of new stuff.
Yeah, like even the robot guy in the Star Wars, forgot what's name. The
C-3PO?
Yeah. And now we have this circular vacuum thingies that goes around the house and vacuum if you want them to do that. They're still not as fancy as him.
I think C-3PO would be offended if you just told him he's essentially a fancy vacuum cleaner.
Yet. It's like we're still developing until we get there. But like the idea of having such a thing was very far in the 70s.
Yeah, and progress is happening at an ever-increasing rate. More scientists looking into new things.
So yeah, we need wild ideas.
Yeah, I think that is an excellent line to end this episode on. Do you agree?
Yeah.
Brilliant. So I hope you've enjoyed listening to this, and we have lots more wild ideas coming up in the future, so stay tuned and we'll see you next time. The views expressed in this podcast belong entirely to the person that said them. They do not represent any industry or organisation. If you enjoyed listening to these views, it would really help us out if you could rate us, leave a review and tell a friend. This podcast was sponsored by no one, but if you're interested in funding us to continue to have frank discussions about science and engineering, please get in touch.